Welcome back, everyone. Ready to dive into some seriously complex stuff?
Oh, absolutely. Always up for a good brain workout.
Well, today's deep dive is all about quantum data encoding, and we're going to be using this fascinating essay by Jurgo Schneppat as our guide.
Schneppat, huh? Great choice. He really knows his stuff.
He does, and he doesn't shy away from the details. I mean, we're talking about using the weirdness of the quantum world to store and process information. It's mind-blowing stuff.
Yeah, it's like stepping into a whole new dimension of computing, almost like science fiction becoming reality.
Exactly. Schneppat even compares it to magic at some points.
Well, in a way, it is a bit like magic. I mean, think about quantum phenomena like superposition and entanglement. Things can be in multiple states at once, and particles can be linked across vast distances.
Right. And Schneppat explains how those very concepts, the ones that seem impossible to us, are the keys to unlocking the potential of quantum data encoding.
It's all about harnessing that weirdness and turning it into something that can revolutionize how we use and interact with information.
Okay, so let's break it down a bit. I always struggle with superposition. It's like trying to grasp something that's both there and not there at the same time.
I know, it's a bit of a head-scratcher, right? But think of it like this. Imagine a coin spinning in the air. It's not heads, it's not tails, it's both possibilities existing simultaneously until it finally lands.
Okay, I think I'm starting to get it. So instead of bits, which are like a light switch that can be on or off, we have qubits, which are more like a dimmer switch with a whole range of possibilities.
Exactly. And that's where the power comes in. A qubit can exist in multiple states at the same time, which means a quantum computer can explore many possible solutions to a problem simultaneously instead of one at a time like our current computers do.
So we're talking about exponential speedups for certain types of calculations, right? Schneppat gets into the pretty intense detail about how this actually works in terms of encoding data.
He does. And, he's really adamant about understanding the mathematical foundations of quantum data encoding. It's not just about the theoretical possibilities. It's about having the tools to actually manipulate these quantum states in a precise and controllable way.
So the math is the key to turning these quantum quirks into something practical.
Exactly. And that's one of the things I appreciate about Schneppat's work. He goes beyond just the wow factor and really digs into the how and the why.
And speaking of wow, Schneppat doesn't just talk theory. He highlights some real-world applications that are already starting to emerge.
Oh, absolutely. Like quantum cryptography, using those mind-bending quantum principles to create communication systems that are theoretically unbreakable.
Unbreakable codes. That sounds like something straight out of a spy movie.
Well, it might be closer to reality than we think. Schneppat argues that quantum cryptography could revolutionize online security. I mean, imagine a world where hacking is impossible because the very laws of physics are protecting your data.
That would certainly make me feel safer online.
Right. And that's not all. Schneppat also talks about quantum sensors devices that can measure physical quantities with incredible accuracy, all thanks to the sensitivity of quantum states.
He even mentions potential applications in medical imaging. I mean, imagine being able to detect diseases at the molecular level long before any symptoms even appear.
It's like having a superpower, right? Being able to see the invisible and understand the world at a level of detail we've never been able to before.
But as with any powerful technology, there are challenges to overcome. Schneppat doesn't shy away from the difficulties, does he?
Not at all. In fact, he dedicates a good chunk of his essay to discussing the roadblocks we still face, like decoherence.
Decoherence. That sounds like a villain from a superhero comic.
Well, it's not quite that dramatic, but it is a serious obstacle. Decoherence is basically what happens when a delicate quantum state collapses due to interference from the environment, things like noise and temperature fluctuations.
So it's like our spinning coin finally landing, losing its both at once magic and becoming just heads or tails.
Yeah, a good way to put it. Schneppat emphasizes that overcoming these challenges is crucial to building practical quantum computers and communication systems.
So it's not just about understanding the science, it's about engineering solutions that can protect these delicate quantum states from the messy real world.
Exactly. And that's what makes this field so exciting. It's a constant push and pull between the theoretical possibilities and the very real limitations we have to overcome.
Schneppat really captures that sense of pushing boundaries, doesn't he?
He does. And in the next part of our deep dive, we're going to explore his vision of what's coming next in the world of quantum data encoding.
Oh, these say I've got to hear.
Get ready for some truly mind-bending ideas about new quantum algorithms and even more powerful quantum processors.
Stay tuned, folks. Things are about to get really interesting.
All right, so we've talked about the challenges, but Jirgo Schneppat doesn't stop there. He's really looking ahead, towards the future.
Yeah, he definitely paints a picture of what's coming next, especially when it comes to those quantum algorithms we mentioned.
Right, and that's where things get even more interesting. It's like we're not just building faster computers.
We're talking about a whole new way of thinking about how to solve problems.
Exactly. Schneppat kind of compares it to having a whole new cookbook, right? With quantum computers, we need new recipes, new algorithms that can actually take advantage of their unique capabilities.
Okay, so these quantum algorithms are the key to unlocking the real potential here. But what kind of problems are we talking about? Give me some examples.
Well, Schneppat talks about fields like drug discovery and materials science. Imagine being able to design new medicines by simulating complex molecules at the atomic level, or even creating entirely new materials with properties we can't even imagine right now.
That sounds incredible. It's like we could revolutionize entire industries.
It's definitely a possibility. And it goes beyond just those specialized fields, too. Schneppat also mentions optimizing logistics and financial models. Think about streamlining global supply chains to reduce waste, or even creating more accurate financial predictions to avoid economic crashes.
Wow, okay. So we're talking about some pretty big implications here, not just scientific advancements, but real-world impact on a global scale.
Absolutely. But, of course, with great power comes great responsibility, right? Schneppat also touches on the potential for these quantum computers to crack the codes that protect our online information. It's like a double-edged sword.
Yeah, that's a bit unsettling. I mean, on the one hand, we could have enhanced cybersecurity, but on the other hand, someone could use that same power to break the encryption that protects our privacy.
Right, and that's why Schneppat is so adamant about the ethical considerations. It's not just about building the technology, it's about making sure we use it responsibly.
So, anticipating the potential downsides and really thinking through the implications before it's too late.
Exactly. He argues that we need to start asking some tough questions now. Like, how do we ensure that access to quantum technology is equitable and doesn't just widen the gap between the haves and have-nots?
Right, because we don't want this technology to just benefit a select few. It has the potential to impact everyone.
And that's what I appreciate about Schneppat's work. He's not just focused on the technical aspects. He's thinking about the big picture, the societal impact, the ethical dilemmas. It's almost like his essay is a philosophical treatise as much as a technical explanation.
Yeah, it's definitely pushing me to think beyond the science. I mean, the potential benefits are mind-blowing, but the potential risks are real, too.
It's almost like we're standing at a crossroads, isn't it? The path we choose will determine what kind of quantum future we create.
And Schneppat is giving us the tools to make those choices, to have those conversations, and hopefully steer things in the right direction.
He is. And in the next part of our deep dive, I actually want to leave you with a thought experiment, something that really gets at the heart of these ethical dilemmas, something inspired by Schneppat's work.
Oh, a thought experiment.
Yeah.
Now you got me curious. I'm all ears. Okay, lay that thought experiment on me. I'm ready to have my mind blown wide open.
All right, so imagine you have access to a quantum computer. Not just any quantum computer, but one powerful enough to break any encryption in existence.
Okay, now we're talking. That's some serious power, like something out of a spy thriller.
It is, right. And Jirgo Schneppat really wants us to think about this because it might not be so far-fetched in the future. As these quantum computers get more advanced, the security of our entire digital world, everything we rely on, could be at risk.
So in this scenario, I'm basically holding the keys to the kingdom. Financial records, government secrets, personal messages, anything is accessible.
Exactly. And that's where things get ethically tricky. Schneppat asks us to really think about the implications. Would you use this power? And if so, how? What are the consequences?
It's a tough call, honestly. Part of me thinks, yeah, expose corruption, bring hidden truths to light, but then there's that whole invasion of privacy thing. Where do you draw the line?
Right. Who gets to decide what secrets should be revealed and what should remain hidden? It's like opening Pandora's box. Once that information is out there, you can't put it back in.
Schneppat doesn't give us easy answers, does he?
Nope. But that's kind of the point. He wants us to grapple with these questions now, before this technology becomes so powerful that it's out of our control.
So this isn't just a hypothetical thought experiment. It's a warning, a call to action.
Exactly. It's about recognizing that quantum data encoding isn't just about cool gadgets and scientific breakthroughs. It's about confronting some fundamental ethical dilemmas about power, privacy, and the very nature of information itself.
It really makes you think about the kind of future we're building and the choices we're making today that will shape that future.
And ultimately, that's what Schneppat's essay is all about. It's a reminder that we're not just passive observers in this quantum revolution. We all have a role to play in shaping what it looks like and ensuring that it benefits all of humanity.
Well, I've got to say, this deep dive has definitely given me a lot to chew on.
Me too. And, if you're out there listening and feeling a little overwhelmed by all this, that's okay. The important thing is to be aware, to start asking those tough questions, to engage in these conversations.
Because the quantum future is coming, whether we're ready or not.
Exactly.
So a huge thank you to Jorgo Schneppat for giving us so much to think about. And to our listeners, thanks for joining us on this mind-bending journey into the world of quantum data encoding.
Until next time, keep exploring, keep questioning, and keep diving deep.
And remember, the future is in our hands. Or maybe I should say our qubits.